So when we'd like to distinguish between neoplasm and tumor, these terms may be used interchangeably, and tumor, of course, more colloquial way to put it, and neoplasm is a new growth that can be either cancerous or benign. We still need to remember that not all the tumors and neoplasm are deadly, and not all of them are malignancies. However, again, approximately 1.3 million people are diagnosed in this country with malignant neoplasms every year, and this includes all types of cancers, treatable very well and non-treatable. And of course, we need to know, for the purposes of this course and in general for your further development in practice, that which are the common cancer. So for men, prostate cancer is the most commonly diagnosed, and for women it's the breast cancer. Cancers again can be diagnosed many different ways, and one of the important points, the earlier cancer diagnosed, the better treatment can be. This is a generalization, but most of the time that works. And cancers are classified according to their appearance, growth patterns, and which is one of the important points here, type of body tissue, where they came from. Normally cells have the programmed death called apoptosis, while cancerous cells can divide indefinitely. So there is no apoptosis in cancerous cells, and they are not only surviving, but they also continue to replicate. And when telomeres shorten with each replication in a normal cell, eventually it comes to the point when the cell isn't able to divide, and but still the telomeres are restored by enzyme telomerase. So when the cells, when the telomeres become too short, the telomerase doesn't work anymore. While in cancer cells, telomerase is activated and it keeps repairing the telomeres until indefinitely, and the cancerous cells can replicate because telomeres are maintaining their length, and they are able to, or they are enabling the cell to replicate. HeLa cell is a cancerous cell that has been obtained from a young woman, 31-year-old Henrietta Lacks, upon her death from cervical cancer. It was in 1951, and the cells are still living and multiplying. I'm sure you probably heard about the contribution that it made to science and to overall to medicine and different aspects of human activities and developments. To name a few, these HeLa cells were used for polio research, and in 1955 the vaccine was created that was helping and which helped to nearly erase the polio disease. But again, HeLa cell is slightly different from other cancer cells, because when at that time in early 50s the cancer cell samples were obtained, they usually would replicate for a short time, but they eventually would die outside of the host organism. However, the HeLa cells would multiply uncontrollably, and some scientists speculate that the total weight of all cells that multiplied from the original HeLa cell samples is about 20 tons or more. And again, this is an interesting issue, and part of it is an issue in bioethics, and I will stop right here after saying that the tissue samples were obtained from the patient, from Henrietta Lacks, without her consent, and you can further research the issue and discuss in your ethics class if you'd like to, but to me it's very fascinating, and you may research about the further development. But again, to complete this slide, we need to remember that the telomerase is activated in cancer cells, and they will continue to divide, and HeLa cells are the perfect example of that. Normally, even with all the genetic abnormalities, tumors cannot grow without blood supply. Blood supply, as it was said, needed for tumor growth as well as for metastasis. So in normal situation, in healthy body, angiogenesis only occurs in two cases. First of all, in wound healing. We'll know both in secondary and primary wound healing, the angiogenesis will occur, and also in the uterus during the proliferation stage of the menstrual cycle. But otherwise, the angiogenesis is pretty abnormal process. I mean, if there, except those two cases, and angiogenesis will be one of the signs of tumors, tumor growth. This is the article one we talked about it, and the one I wanted you to review. So the research was carried out using THIABENDAZOLE or TBZ, which is quite common antifungal drug, but it has been shown that TBZ would inhibit angiogenesis in vivo in XENOPUS embryos. And XENOPUS is, I put a picture here, it's one of the cornerstone of modern genetic research, and especially the embryonic research on embryos of XENOPUS, because genetically they are fairly similar to human cells, and they are good subjects for research. And I don't know if there is a monument for XENOPUS somewhere, but they certainly deserve it. And on these pictures you see two computer-generated images, which one is in control session and the other the XENOPUS embryo that is in TBZ environment. And the embryo with TBZ, you can see that the vessels aren't developed. The vessels are missing, where on the normal embryo they are present. And there are several pictures, but I think the most prominent ones are E and F pictures, where you can see the highlight and contrast of pictures. And again, XENOPUS embryos have been used in research for quite a long time, and there is a special contribution to science by these frogs and the role they served in genetic research. How malignant transformation occurs and what are the steps? First of all, initiation phase. In initiation phase, the cell damage occurs and it changes the genes that normally would keep the cell from malignant changes, and these are tumor suppressor genes, apoptosis agents, and they transform to promotional period or latency period, time between the cell's initiation and into actual tumor. The tumor, the detectable tumor. The growth is still occurring, but we have no means to detect it at that point. So last phase is the occurrence or emergence of the detectable tumor, and it's quite small still. It's about 1 centimeter in size, but 1 centimeter in size means that we have 1 billion cells already. So the growth is exponential growth, and cell rapidly divides. If we bring the example of HeLa cell we talked about, in HeLa cells the growth doubling time is only 24 hours, while normal cells may take 36. So these cells, the malignant cells, have, in addition to uncontrolled growth, they have faster growth time compared to normal cells. Grading and staging are two important concepts in cancer diagnostics and treatment, and they're important because they allow us to determine the development of the disease, the extent to which the disease is developed, and plan the treatment accordingly, and also predict the possibility of cure. When we talk about grading, we are talking about the degree of differentiation. If tissue is well differentiated, like a normal tissue, that's lower grade, that's grade 1. If tissue is very similar to normal tissue, it's grade 1. When differentiation starts to disappear, the grading will increase. So grade 4 will be much less differentiated versus grade 2. Most of the time the grading will be numbered by Roman numerals from 1 to 4 Roman numerals. However, in prostate cancer case, we may use 5 stages of, 5 grades for grading the malignancy, and that obtained by using Gleason grading. In Gleason grading, again, we're looking to differentiation of the tissue, and again, grade 1 will be very similar to normal tissue, very well differentiated. When we're going to grade 5, it's undifferentiated. The color changes here, it's the artistic interpretation. More red means more cancer, the higher grade, but in reality, of course, the cells won't be changing from green to red. But again, it's the degree of differentiation. The next concept is staging of the cancer, and staging determines the extent of spread of neoplasm. We can develop staging from clinical examination, imaging studies, biopsies, and even surgical exploration with biopsies. So staging, again, performed by numerical numbers from 1 to 4, and the system is very similar to grading, but again, staging is spread and grading is differentiation or degree of abnormality. So staging will show is it's how well spread the cancer is. TNM system can be used for staging, And in that system, tumors are staged according to the size of the extent of primary tumor, number of lymph nodes involved, and metastases present in the other remote sites. So, but here on this, with this simple staging, representation in this picture, and again, depending on the extent of metastasis, invasion of the tissues, the staging can be performed. So in this staging system, stage 0 will signify carcinoma in situ. Stage 1, stage 2, and stage 3 basically reflect the extent of the disease. So is tumor big or small? Did it spread beyond the organ in which it first developed? And is it in lymph nodes and organs that adjacent to the location of primary tumor? And stage 4 will be the cancer spread to other organs. TNM system is an important classification system, and it gives you better idea of what's going on, and that compared to simple staging system. So if we have TNM, under T we are examining the primary tumor and its size. The primary tumor, if it cannot be evaluated or there is no evidence of primary tumor like carcinoma in situ, you can put T0, and N stands for regional lymph node. And if we have carcinoma in situ, we can put T0, N0 in this case, and also add CIS, like abnormal cells present, but they didn't spread. When carcinoma in situ becomes cancer, we may have the size of the primary tumor described as T1, T2, T3, T4, size and extent of primary tumor. So T is always the primary tumor. And as I said, it was referring to lymph nodes. If there is nothing in the lymph nodes, you may say N0, and if there is some involvement goes on in you may place a number then, N1, N2, and they reflect the number of lymph nodes and the extent of spread. So distant metastasis, if there is no way to evaluate those, it's M0. And if, let's say, there is one, M1. So let's look at these examples. Breast cancer example, we're looking at T3, N2, M0. So T3 reflects relatively large number, large tumor that's spread to nearing lymph nodes, but thankfully not to other parts of the body. There is no metastasis. The next example is prostate cancer, T2, N0, M0. This explains to you that the tumor is located only in the prostate, there is no lymphatic spread, and there is no metastatic spread. So this is very very bright prognosis for this patient, because this can be operated, and depending on findings, he may or even may not require any further chemotherapy and radiation or other treatment modalities in this case. But again, to recap on all of this, all stagings and gradings, these are subjective systems. Unfortunately, there is no such a thing as a ruler to put on patient and measure staging and grading. So these are all interpretation, but because of consistency of the standards of staging and grading, this may reflect relatively well the condition of what happens, the condition of what happens to the patient. So again, staging will show you the size and the extent, and grading is differentiation. So staging basically what happened to the tumor, and grading how bad they are. And you may develop your own systems how to memorize this, but again, zeros in TNM system are good, and numerical values, the greater it is, the worse is usually the prognosis. I put a link here from cancer.gov, and it's very simple explanation of staging, and I actually took the examples of breast cancer and prostate cancer from there, and you can read it if you are interested to learn more about staging and grading, but this slide gives you the essence of the TNM system.